I am deeply honored to introduce today's guest, Abdullah Atalar, a distinguished applied physicist and former rector of Bilkent University. He has had a remarkable journey marked by academic excellence and impactful leadership. From his early days as a top student, graduating with a perfect 4.0 GPA from Middle East Technical University, he showcased his commitment to learning and research. His academic journey laid the successful foundation for a career bridging academia and industry, offering valuable insights into their similarities and differences. At Stanford University, Abdullah Atalar gained further experiences that influenced his perspective on education and research. His tenure as rector of Bilkent University for 12 years allowed him to understand the intricacies of university leadership, making important decisions that shaped the institution. Dr. Atalar's dedication to improving higher education is evident in his work on innovative funding solutions for universities in developing countries, addressing critical global challenges in academia. Throughout his career, Atalar's passion for advancing imaging techniques, particularly in acoustic and atomic force microscopy, has been central. His pioneering work in these areas showcases his commitment to scientific exploration and precision. Looking forward, Abdullah Atalar continues to explore new research frontiers, demonstrating his unwavering commitment to the pursuit of knowledge and the advancement of applied physics. His life and career stand as a beacon of inspiration for those aspiring to make a significant impact in the world of science and education. Here is our conversation. Please welcome Abdullah Atalar. Accepting the invitation. You have been at the first place wherever you went, starting from high school and most likely even from before. You are an inspiration to many, so can you paint me a picture of how your life has evolved and what created your interest in research?
Okay. Well, I was born in 1950s.
Yeah.
About 9 years after the Second World War, in Anatolia, in Gaziantep. At the time, the schools in Gaziantep were not yet good enough. So my father decided to take our family to Ankara so that we can get a better education.
Sure.
So when I was, well, actually, first year, I went to school in a village school in Hirfanlı.
Wow.
Because I knew how to read and write before coming to school, they started me at the second year. Nice. So I was always 1 year younger than my classmates.
Yeah.
By the way, this is not a very good idea. Because you are always shorter, you are always weaker, and even though I was interested in sports, I was never in the sports team of the class.
Sure.
So I always was the small kid. Anyway, then after 1 year in that village school, then we moved to Ankara. And then I started school in Ankara. I finished Alparslan İlkokulu, right next to Bilkent Hospital.
Oh, nice.
And then I continued my middle school education in Denemeli Ortaokulu, Denemeli Lisesi.
Okay.
And then I was one of the top 2 or 3 students in my class.
Right.
Not the top one, but top 2 or 3. And that made me qualify for entrance to Ankara Science School exam, Fen Lisesi exam. At the time, not everybody can enter the exam.
Yeah, of course.
In its first years, Only the select students from all schools in Turkey were able to attend.
Yeah, only the most talented, sure.
Not because of that. It's to provide diversity.
Ah, right.
So that the kids from far parts of Turkey have a chance to study in Ankara Fen Lisesi.
Yeah, that's actually a good idea.
Yeah. Later, that idea was changed. That rule was changed. I think it's for bad. But at first, I don't know how many years, this was the way it is.
Yeah.
And it's actually, there is in New York, there is a school called Bronx School of Science.
Yeah.
Ankara Fen Lisesi was modeled after that school.
Oh.
With and that's the way they were taking students in. From every student, every classroom, top 2 or 3 students take the exam, and among them, they choose the best ones. But that makes diversity in the classroom. For example, in my classroom in high school, there were people from Edirne and Ardahan.
Wow. Yeah.
Very diverse school.
Yeah.
Really, very diverse school. Well, in middle school, I was interested in science.
And how did that start?
Well, actually, there wasn't many things that we could be interested in. There was no internet. There was no books. Even books, I'm talking about 60s, early 60s. You cannot even buy books.
Wow.
I read all my books several times each. I had a few books. And interesting things were things in my science book, in the class book, textbook of the science class was interesting.
Yeah,
because there were things about electrical measurements, and I remember a thing that measures the static electricity. I built one myself, and I was
in high school.
In elementary, in middle school.
Wow.
So that was something, to show around and to be proud of. So I was interested in batteries. I tried to build a battery using lead acid battery.
Oh, lead acid.
Lead acid battery. Because at the time that was the only type of battery. Lead, I bought lead. I, with my little monthly allowance, I also tried to buy sulfuric acid.
Wow.
Tried to make a lead acid battery. It didn't work, but I tried anyway.
Yeah, that brings you so many knowledge that you can.
And then I started in the high school. Ankara Fen Lisesi. At the time, it was the only Fen Lisesi in Turkey, and we had just for an experimental lover, it was a miracle at the time. At the time, not anymore, but at the time, I remember our chemistry lab was full of thousands of chemicals.
Wow.
Coming from United States. It was modeled after Bronx School of Science, and everything was new. We had weighing scales that can measure milligrams. We had all kinds of chemicals. Yeah. Chemistry lab was incredible. And then biology lab was incredible. We had microscopes. And we had very good teachers. The selected teachers were also very select ones. And they've actually gone to the United States to learn the material that
they're supposed to provide.
They're supposed to write. And actually some of them were translators of the books. And the science books, all science books and mathematics books were the result of America's they were translated from American textbooks, and they were special textbooks written by Nobel laureates.
Awesome.
In 19 late 1950s, when Russia, at the time of course Soviet Union, was into the space first, ahead of United States. United States Congress worried a lot. They said, we thought we were they thought we were ahead. And they said, we are not ahead. Yeah, Soviets are ahead of us. Now we should invest more in science education. So United States Congress passed a bill to write 4 books.
Yeah.
Mathematics, physics, chemistry.
And those 4 books?
And those 4 books are the ones we studied.
Wow.
And interestingly, mathematics book contained what we call now modern mathematics, contained sets and stuff like that. But not a whole of a lot different than regular mathematics.
Surely.
Physics book was great. It was written by MIT.
Oh.
Professors in MIT wrote the book. Oh my God. It has everything. Einstein was in it.
Wow.
It was very advanced book.
Yeah.
It was a very advanced book. And the problems were very difficult at the end of each chapter.
Is it still available?
Yes, it is still available.
Awesome. Yeah.
It's called PSSC books.
Okay.
When you enter, I think you can find in old
libraries.
Well, not just libraries. They may be selling some of them in old bookstores or stuff.
Yeah, for collectors.
And chemistry book was excellent also. And every textbook every week there was a lab.
Oh, yeah.
I remember our first chemistry lab. They gave us one candle. Yeah. Light the candle and describe.
Oh.
That's it. This is the experiment number 1. Light the candle and describe.
But the report should be
well.
Yeah.
You know, why there is this blue portion, is it hot, is it cold? I don't know. You can do a lot of experiments and write a good Yeah, it's not like a menu type experiment. Do this, find that. No, it's not like that. You do your own.
Nice.
Okay, and the biology book was incredible. It had 2 chapters. The first chapter is evolution. Second chapter is DNA.
The biggest. Yeah.
And these were written by Thomas Watson, who got the Nobel Prize for discovering DNA.
Yeah.
Some 5 or 6 years ago, in 1954.
Wow.
They discovered that, and they wrote the book under his biology book was under his command. He was one of the authors of the book. And our biology teachers went there and talked to him and learned from him, and then came and taught us.
So you really
I was very lucky.
The giants.
I was very lucky to be a student at that time in that high school. So that's one of my lucks, I should say.
Yeah, definitely.
This book, the other 4 books, total of 4 books, and the 3 books, when these books are ready, in federal government in the United States sent these books to everybody in the United States, all districts. They said they do not have the authority to impose the books on schools. Only thing they can say, they can offer. So there are, I don't know how many districts there are in the United States, but some of them adopted some of the books, but the biology book was adopted in no district in the United States. The reason is because there was evolution inside.
Yeah.
Okay? And then when, of course, Thomas Watson was very disappointed because his book was not being taught in any school. But at the time, Ankara Fen Lisesi said, we will take this book and use it. And so it was the first high school in the world to teach DNA and evolution in the high school level.
That's really...
And it was so exciting that Thomas Watson, the Nobel laureate, came to Ankara and visited our high school.
Did you have a chance to meet him?
No, actually, this happened a year before I entered.
Oh, no. But still, yeah, very good.
I know, I saw pictures of him visiting the high school, but I wasn't in the high school at that year.
I see. And how did your interest evolve?
So I really liked chemistry. I was thinking to become a chemist.
Yeah.
I like also physics. I was thinking, should I become physicist or chemist?
Yeah.
But in the third year, we had an elective course, electronics.
Nice.
Fourth year, electronics course.
Yeah.
And we had kids that had come from the United States. At the time, even though transistors were invented some 10 years ago, the kits, electronic kits that they had was tubes, vacuum tubes. Nevertheless, and at the time, actually, in the high school, I started experimenting with transistors as a hobby. So electronics was something that I tried to learn. Sometimes I learned, sometimes I didn't, and so on. And then when this electronics, of course, I took that course. I learned something, not much, because I knew most of them already. But at that time, I decided to be electrical engineer. You know, it's anyway. So
that elective course changed your perspective on the...
yeah, in the high school, my hobby actually directed me towards that direction. I was building small radios, you know. Yeah. And as I said, at the time there was nothing a youngster can do. There was no, you know, internet. There was no Netflix. There was no there was no Spotify. Nothing, right? Yeah. So I was. The stuff that I'm trying to build, and that was a Turkish radio amateurs monthly journal. I was getting that, and I was trying to build the stuff that's in it.
And who was providing you with the tools? Yourself?
Well, I didn't have tools. My allowance. Using my allowance. I remember I bought my first transistor using one month's allowance. Wow. So you can see the price difference now. Now the transistors are dirt cheap, but at the time it was expensive.
Sure.
And so I invested on my own.
I see. And you have graduated from University of METU with 4 GPA, which everybody talks about. What are some tips you can give for those who are trying to do the same? And what kind of sacrifices did you have to make in order to achieve this?
Well, it turns out that I wasn't the person that was studying very hard, but I was, when my friends asked me some questions, I was helping them, and when I'm trying to teach them something, I was learning even better. Yeah. So there I really loved teaching. So not just science, but teaching was also something I liked, because my friends asked me questions and I would teach them something, and that was great.
Yeah.
And I don't remember actually at METU at the time we didn't have homework assignments. I don't remember ever studying past 9 p.m.
Yeah. That's awesome. Sad for us.
I think, if you are motivated to learn things, That's an important thing. So you have to like what you're doing,
yeah, of course.
And that brings, I think, success.
Yeah, definitely. But what else? I mean, you can study hard. You can also have the joy of doing it, but sometimes you can't really achieve what you want. Do you have some insight into how to achieve under situations like this?
Let me tell you one story again about electronics. In the high school, I was building a circuit that's coming from this monthly journal.
Mm-hmm.
The one transistor radio. It works so great. Just one transistor and it works nice. Yeah. Incredible. You can take faraway stations, shortwave radio station, shortwave radio broadcast. At the time, remember, there was no internet.
Yeah.
The only external information that you can hear is radio.
Yeah.
There is no TV, mm-hmm. just radio. So radio was very interesting at the time. Mm-hmm. So I built this radio, shortwave radio. It was working so great, mm-hmm. but I didn't know how it worked. I had no idea why it worked.
Yeah, you just assembled it.
I assembled it, tuned it, and it works. But I'm very curious how it works.
Yeah.
So when I went to the university, mm-hmm. Middle East Technical University, electrical engineering, mm-hmm. I said, I'll ask my professors. I asked them, how does it work? Mm-hmm. So in my first week, I went to a professor of electronics and I said, can you tell me how this thing works? He has no idea.
Oh, oh no.
He has no idea.
How is that possible then?
He had no idea.
Okay.
Not that he's not good,
yeah.
but he just didn't know it.
Mm-hmm.
Okay. So I said, okay, nobody knows here, but maybe in the and the METU has a great library. Mm-hmm. So I went there.
Maybe I can learn it from there. Yeah.
So I went there and I said, I'll find out how this thing works. Mm-hmm. I went through all the books. None of the books explains how this thing works. But there is a mention of a 1920 paper.
Okay.
That says, it explains how this thing works. Mm-hmm. But 1920 paper,
it's not really relevant.
METU library didn't have those.
Yeah.
And you cannot access, remember, there is no internet. You cannot access anything like in our library.
You go to another university and
yes,
take the paper.
It's impossible. So it's just not there. Mm-hmm. Things after 1960s were in the library, but not in 1920s.
Yes.
So I tried to learn, but I never learned it until I graduated. Then I applied for master's and PhD studies in the United States after graduation. Mm-hmm. And I made my applications to 3 universities: MIT, Stanford, Caltech.
Yeah, the best ones, sure.
I remember typing my CV in a mechanical typewriter, each one separately.
Of course.
And then I got accepted from all 3.
Awesome.
They were offering scholarships and so on. But I don't know which one to go.
Yeah, of course. How did you say?
Well, I went to the METU's library, and they had catalogs of the universities. Mm-hmm. I took the catalog of Caltech. It was thin. Mm-hmm. I said, I'm not going to go there. I looked at the Stanford's catalog. It was pretty thick and it had lots of things inside, many courses, many departments. Yeah. I like that. And a nice picture in front of the campus.
Sure.
And then I looked at the MIT's catalog. That was also big. But the course labeling system was different.
You didn't like that?
I didn't like that. I mean, the Stanford's course labeling system was like a METU's, you know, EE 201.
Yeah.
Something like that. Stanford's also like that. But MIT's was different. They had just these numbers.
And that's how you decided.
That's how I decided.
What a different life it could have been. Wow.
Yes, it's. So I went to Stanford, and I think in the first week I went to the library to find how this radio works.
And this time you did.
Well, then I went to the library. I said I want this, that journal's 1920 versions were not in the regular open access portion. It was in the in the storage.
Restricted
storage.
Okay.
Because it's very old. But there is a way of doing it. You have to fill a form. You have to give the name of the paper. And then pay for the photocopy cost, then they'll give it to you.
Okay.
So in 2 days after that, I got the.
You got the paper.
I got the paper.
Fine.
So I started reading. Wow, it was so genius.
And you find out.
Yes, then I learned how that thing works.
Okay. Great story. You have also worked on both academy and industry after graduation. What can you tell me about the similarities and differences? What kind of skills do they specifically require? And which one did you like the most?
Well, after getting my PhD, by the way, I worked with a very great scientist. He was my mentor. And great human being. Not just a great scientist, also a great human being.
Yeah,
so it's very important. And after graduation, actually, he helped me find a job. But he wanted me to also continue with him working as a postdoc. So I...
really offered.
Yeah, he found... he recommended me to Bell Labs. Bell Labs was at the time top laboratory in the private sector. You know, Bell Labs is the one that invented the transistor and many things. They had a scientific journal of their own.
Very innovative. It's still is, I believe.
No, not anymore. But at the time, it was a great place. So I went there, and they offered me a job, but somehow I didn't like the
way they
I didn't like the subject area that they asked me to work on. I didn't like it.
What was it? Do you remember?
It was in image processing.
Image processing.
I had very little information about that at the time, and they asked me to work on image processing because I had experience with microcomputers and computers because I was in the Bay Area, in the what's now called Silicon Valley, just when the microprocessor was being invented and Bill Gates was developing his Microsoft, and Apple was just... I was there in the very same region at the very same time. And also I was interested in building things, so I actually built a microprocessor, a microcomputer of my own. And I took the first microprocessor class given in Stanford by an Intel engineer. None of the professors knew how it worked, but so they invited an Intel engineer, taught us. So I took the first class. That was in 1976. So I knew also about computing, programming, and that sort of thing. in addition to my well, it's more. I did my PhD in applied physics lab, so it's somewhere between physics and electrical engineering.
Sure.
Anyway, after graduation, I went to HP Labs. HP is another important company, and that was the research lab of their company. And I worked there for 1 year. And I finished the project that I was assigned.
You did your PhD in 1 year?
No. HP Labs. This is after I finished my PhD. I got my MS and PhD in 4 years. But after getting a PhD in 1978, I worked 1 year as a postdoc at Stanford. Then I worked at HP Labs.
I see. Okay.
But after that, I decided to return. I was probably the only person who returns to Turkey at the time.
Yeah.
They said, "Why are you returning?" I said, "I will return."
Did you always knew you were going back, or?
I always knew that I was going to come back.
Okay.
And looking back, I'm glad that I did come back.
Yeah, sure, we are too. But how do you take that decision? And do you recommend others to do the same? Or?
Well, that's their own decision.
Yeah, of course.
Everybody makes their own decision.
But you are happy that you did?
Yes,
okay.
I'm very happy that I did.
Can you tell me about the experience in Stanford in general, and which difference do we have to Stanford, who we are trying to look up to, I guess, as a university?
I think, our Ali Doğramacı is also a Stanford graduate.
Yeah.
And when Bilkent was being founded, many things are taken from Stanford.
Yeah, sure. Inspiration, of course.
Like Stanford has a shopping center, we have a shopping center, okay, to support the university.
Yeah.
Income supports the university. Stanford's catalog and our catalog are similar in size and looks and so on. So we have been inspired by Stanford. So when you look at the difficulty of courses and stuff like that, and that's also very similar. So when our graduates go to these top universities, they don't feel like things are very hard. They say, "Oh, this is similar to what we are."
Yeah, and that's how it's supposed to be, I guess. I even just before coming, I heard how great your lectures are. What do you do differently, and what advices can you give to the new teachers? Students.
Having students interested and keeping them, making them learn in the classroom is an important thing. I learned this from one of my professors at Stanford when I was taking statistics course during summer. During the hot summer, it was a summer course, so it's half as long. That means there are twice as many classes per week. And it's statistics. Not necessarily very entertaining.
And
But this guy, this professor, made us listen to him every little second. How did he do that?
Because he himself was interested, I guess.
Well, he was, of course, very motivated and so on, but there was some technique that he was using.
Okay.
And this is the technique I'm using now, still.
So what is it?
And it is that, when I'm writing something on the board, right now I'm using my pad to write on the board. I ask the students, one by one, next. What do I write next? They tell me what to write next.
Okay.
And they know I don't have to call their names. I just say next, and the next guy tells me what's the next term is.
Wow.
And then next. In 1 hour or 2 hours, the whole class needs to answer. Participate, and they need to be
on edge.
They have to be watching. I don't give grades to this.
Yeah.
No grades,
but still there is some pressure.
There is some, peer pressure.
Yeah.
If you say, oh, I don't know, and so on. Well, if they hesitate, then I move to the next person.
Yeah.
It's okay, but of course they don't want to be in that situation, so they try to understand what's going on, so they follow.
That's
so,
actually perfect.
So then this is what makes everybody. In my class, there's no student who's looking at their salary form.
Yeah.
Impossible.
Yeah. You have been our rector for 12 years. From 2010 to 2022. What was it like to be in charge of the university, and what are the best and worst parts of being a rector?
Being a rector is very difficult.
Yeah, I can't.
It's
but probably I can't.
it's not something to be you don't want to be a rector. If you want to be a scientist, be a scientist. Being a rector is difficult because you're always the bad guy.
Yes.
The reason is when somebody asks for something, if it's already within the rules, it will be done by someone else before it comes to me.
Sure.
The only things that comes to me are the ones that are not
require rejection. Yeah.
They require rejection. But if they get rejection, they come to me, and I have to also reject.
Yes.
And so I'm always the bad guy.
I see.
So you're never a good person.
Yeah, I can imagine that. And what were the decisions you were taking?
So if you look at
what types of?
So if you look at Ekşi Sözlük about me,
yeah, terrible. Yeah, they do that to everybody.
They will, it's fine. I have no objection. They may be right in some of the things, but it's a part of being a rector.
Yeah. And what kind of requests were there that you reject or didn't? I don't know. Like what kind of stuff comes to you when you're a rector?
Well, I don't know. Someone gets a disciplinary action, and they get they have to leave the university for 1 week, and his father calls me. So, and his father may be an influential person. You have to explain them politely why this is important.
Yes.
So you have to be polite to them while still rejecting it.
Yes.
So it's a difficult job.
Yeah, surely. And what were the big decisions that changed the university that you have taken? Do you have any examples of such?
Well, I was rector when this COVID came.
Yes, for example.
When the COVID started, I said, what are we going to do? And then we need to convert the whole education system to online education. And we did that in 3 days.
Yeah, that was actually a success.
3 days.
Yes.
And how did we do that? Well, actually, the Bilkent Computer Center worked day and night to achieve that.
Wow.
And we said, okay, how are we going to do this? And I looked in the internet, and I found something called Zoom. Now everybody knows it. I said, okay, we need a license to Zoom. I had a university credit card as a rector. So using that, I bought licenses of Zoom.
Just yourself?
Yes. But that wasn't enough because the upper limit of the university's credit card was filled up. Then I used my own.
Wow.
And we bought the licenses. And then I started learning how to use it. how are we going to use it, and so on. I tried, because I'm also a teacher, I was also teaching. So being a teacher helped in that respect.
Yeah, of course.
Because I was
know what you need.
Because I was teaching my regular half load of regular professors as a rector of the university. In many universities, rectors don't teach, but I said I will teach because I want to. One thing I like it, and the other is I want to keep in touch with students and find out what the difficulties are and so on. And then once I learned how this is being done. Then, and that weekend, I made Zoom meetings with groups, I think each at 200 at a time, 200 instructors. I sent them email.
Okay.
Look, I want to have a meeting. Just click on this thing, download this Zoom link, and then get in the Zoom and just listen to me. So in those meetings, I explained how the Zoom is going to be used in the lectures.
Okay.
And that weekend, I talked to all faculty members. And then in 3 days, and in the meantime, the university computer center worked day and night to convert the system so that the students get the links and blah blah everything else. And then, so 3 days later, we were able to start. We were the first university in Turkey to start online education like that.
Yeah, I know, and it was, I remember people being disappointed that Bilkent was doing this, but yeah, that was the right decision at the time for sure, and it was quite fast. So yeah, I congratulate everyone also in the Bilkent computer center.
Yes, computer center did a great job at the time.
Yeah, yeah.
And then that was the spring semester of 2020. In the fall semester, we were getting for fall semester. I tried to find out what technologies are available. And I learned about a pad that you can connect to PC and write with a pen, regular pen, not regular pen, its own pen.
Yeah, tablet.
A tablet, but without the screen. You could use, of course, Apple's iPad to write on Apple iPad and then reflect it on Zoom. But not everybody had iPads.
Yeah, sure.
So I found this solution. And then, actually, I bought that, this is called Wacom tablet. I bought that tablet about 10 years ago, before the COVID crisis, for another reason, to be able to write on the PDF files and so on.
Ah, yes.
But I found it very difficult to use, because my writing was horrible when I used that.
Sure.
It was horrible. It was like, elementary school first graders writing. Not very readable.
Yeah.
So I threw at the time, after 10 years ago, I put that aside. I didn't use it. But then on the internet, I learned that people are using it. So I took it back from where it was, and then I plugged it in and I started trying different programs. And then after about 5 or 6 hours, I noticed that my writing is being improved. Because it's a different kind of writing. To write this, you look at the screen and write. It's not like this.
I see. So
it's not like an iPad writing. In an iPad, you write and
what you see.
You see exactly what you wrote. But here, you write it on the screen, so the screen is over here, but you write it over there. So it's a different kind of writing. And after 5 or 6 hours of trying out different things, I noticed that my writing has improved. So I said, this is the way it is. And it was relatively inexpensive. So I again showed it to faculty members, asked them, if you want one, we'll buy it for you.
Okay.
So university bought all Wacom tablets in Turkey.
Yeah, I remember that. And also I remember people getting microphones in one day.
Yes, yes.
Which was also...
Yeah, we bought, of course, cameras, you know, that to be connected, connected to the computers. And at the time, I think we bought all the cameras in Turkey. And that's why other universities fell behind.
Yeah, there is some competition there. What else? Are there any other big decisions that you have taken, or? Yeah.
Well, there are, of course, many decisions that you have to take as a rector. One of the decisions that we took was to impose summer practice requirement for all departments.
Yes, that was a good...
Right now you are in physics and you have...
and I did it, yeah.
Yes, but I think maybe 10 years ago, 12 years ago, there was no... It was a requirement only for few departments. Engineering, and a few other departments.
Applied areas.
Applied, but we said we'll do this for all departments. So that was something...
That actually makes sense.
And I think it helps people learn what's going on in the industry.
Yeah.
Plus, it helps them in finding jobs later.
That's true.
Okay, and then we had some changes in the additional courses because I wanted the students to do extracurricular activities.
Yes, that's
so. This course currently a mandatory course for all students. GE 201 or 250 or something.
Yeah,
that's something. Another thing that we added to curriculum of all departments.
That's actually what keeps clubs alive right now.
Yes,
I can say.
Plus, I think we have the GE 100, which is the university entrance thing.
Yes. Funny thing that was in COVID times. It was very difficult to
collect the points.
So yeah, that's one of the courses that I didn't do well on. Which is interesting, yeah.
And then. Well, a number of things like, I don't know, I try to improve the sports activities. So, sports way of life now, there's a program called. So
that was your adventure.
Yeah, so I said, I'd like to do this.
Yeah. And another thing I can say is the dormitory sports salon, I guess. That's one of the best ones in everywhere right now. And
it's called dormitory sports hall.
Yeah, exactly.
There is a reason for it.
Why?
Because when I was a student at Middle East Technical University, I was interested in sports. And the Middle East Technical University had a great sports hall, but I was never able to enter.
Why not?
Because each time after the class, I go there, school team, university teams usually
filled up always.
They filled up all the major hours. I was never able to play anything there.
Yeah,
so I said,
that's not gonna.
That's not. We will keep the sports hall open to all students all the time, and the university sports team is not gonna be able to reserve a space there.
I see. Yeah.
So that's a result of my experience.
Yeah, thank you for that. Really, thank you for that. This is you stopped being a rector at 2022 after COVID ended and things kind of relaxed. How did you take that decision?
Well, actually, I had to take. It's not my decision.
Yeah, 12 years is the longest.
It's my age. When you exceed 67, you can no longer be appointed rector. But I think 12 years is long enough.
Yes.
And it was also a good time to hand over to another great rector, Kürşat Aydoğan now. I think he's doing a better job than I did. And so it's better to change faces once in a while.
Definitely. I do not mean to question you in any way with this next question I have. I only want to understand the approaches you have taken and the reasons behind them. A lot of people also said before this interview to me, there is a minority, more larger than a minority, that feel unhappy about the university. I'm not even sure I agree with some ways, and yeah, that's okay because nothing is, of course, perfect. But what do you think about that? What can be the reasons why this is so, and what can be done to make it better? Do you have any insight?
Well, there are always complaints.
Yes.
It's difficult, to cover everybody's needs. For example, one of the hardest subjects is the food court. Mm-hmm. Why is it expensive?
Yes.
Stuff like that.
Yeah, that's the usual complaint.
It's a usual complaint. Well, the costs go up. Mm-hmm. We subsidize half of the cost for students. Everybody else pays twice the price as students, and the students still complain. Well, I mean,
you can see, but
I mean, there is nothing I can do about that because we're not government. Yeah. We make our, we have to get along with our own money. We're not printing money, right? We have to earn money, and part of it is paid by students, and part of it is paid by the companies that our great founder, İhsan Doğramacı, founded many years ago, some 40 years ago. And these companies make money, and their money comes to university.
I see.
But after all, at the end of the year, we have to cover our expenses. Yeah. So the students also, many students are on scholarship, and I know the prices are high, but we have to pay our great professors.
Yes.
They have to get decent salaries, and they have to have a good family life so that they can still stay in Bilkent.
Yeah, of course.
It's very important. It's very important that we keep in the last 36 years. We never delayed even one day the salaries. The salaries are always paid on the last working day of the month.
Yeah.
It was never a delay. We never said, okay, we don't have money now, we'll pay it on Monday. We never said that.
Yeah.
So that's important. So financial soundness of the university is very important. And of course, many complaints related to money.
Yeah, of course.
Why is the university so expensive?
Yeah, right.
Well, we have to pay our faculty members. We have to pay our secretaries. We have to pay our, security staff. We need to pay our gardeners.
Yeah, of course.
University has a big campus.
Yeah.
It's 3 square kilometers must be taken care of. We have to pay the security staff.
Sure.
Blah blah.
Yeah.
And I think, and we have to keep them happy.
Yeah.
Right? They have to feel like they are part of the university. The university doesn't belong to anybody. It's a public entity, right? But it doesn't get any money from government.
Yeah.
So, but many complaints have to do with money.
Yeah, that I know. But I'm not only asking about money. Some people complain about the course requirements being too much. But I guess you have taken that from Stanford, so.
Well, they will appreciate it when they graduate.
Yeah.
When they go to, when they start working, they realize that how much they learned, how much they earned in the university.
So you say tough love.
So, our alumni, they say, we were complaining when we were studying, but now we know why. So they will be happy that they studied in this with these difficult courses, but it's an investment in their life.
Yeah, that I agree. But do you think, did you make them harder, or I don't know, did you have any influence? Some people say he made the courses harder.
How can I make
yeah.
How can I make, there are 3,000 courses in the university. How can I make them harder?
I don't know.
I have,
people say
this is the impression they have. Yes, yes, that's true.
Okay, that's at least.
But I asked faculty members to assign homework assignments. That's true.
Okay.
I mean, because homework assignments make you learn, and the projects. We also ask all departments to have a graduation project.
Yes, that helps.
You know, a graduation project is something that requires a lot of time, a lot of work, but you learn a lot.
Yeah, surely.
I mean,
projects is the most.
Plus, you know, it helps you build your CV.
Yeah.
You know, when you write your CV, you have to have something to write there. You say, I did this.
Yeah.
And actually, we have a system. It's not being used much now, but I use it anyway. At the end of course, the students make a 3-minute video of their project and upload it to YouTube.
Yeah, we still have those.
In some courses you do that.
Yeah.
And then these links, YouTube links, are lines in your CV.
Yeah.
And when you apply, they click and find out what you did.
Yeah, that's actually not too bad, I should say. Since you brought up learning, I should also ask, I have seen a recent article of yours about a new way of getting funding for universities that are in developing countries. Can you explain the problem there, and what is the solution you have come up with?
Well, it's not the solution I come up with, it's the solution our founders come up with.
Okay.
İhsan. His solution was, before founding the university, he set up companies. Some of them are the first in Turkey, like he made the first furniture company in Turkey.
Yeah.
In early 70s. At the time, there was no big furniture company. So Tepe Mobilya at the time was the first big furniture company.
Did you know him, by the way? İhsan Doğrumacı?
Well, he invited me. When I was at the Middle East Technical University. He invited me to Bilkent. At the time, there was just one building, which is the library building.
Wow.
His office was there, and he invited me. And
while you were an undergraduate?
No. When I was a faculty member at Middle East Technical University.
Okay, right.
Because when I returned to Turkey in 1980, Bilkent University was not present then.
I see.
I became a faculty member at Middle East Technical University, and he invited me.
Yeah.
And then he offered me the chairperson position for the electrical engineering department.
Okay.
And he explained me about his vision for making a research university. Wow. He said, I'll have this there, I'll have that there. Said,
yeah.
This is so great, a very visionary person. I said, okay, I'll come.
Okay.
So I left Middle East Technical University and came to Bilkent, which had only one building. And the only other building was still under construction.
Yeah.
What's now engineering building, E building, was under construction.
So you took a leap of faith?
No, I believed him, so I came to Bilkent University, and I became one of the first 5 or 6 faculty members.
Wow. Okay. In the 12 years that you worked, you probably have seen a shift in student profile, and you were probably collecting a lot of statistics. Did you observe anything weird, anything new, anything interesting?
Well, the incoming students are getting better and better.
Okay.
I look at the measure I was looking at was the median in entrance ranking.
Okay.
You know, some 2,200 students enter Bilkent University every year. What is the ranking of the median student? You know what median is?
Yeah.
If there are 211, not the most frequent, it's the middle students.
Okay.
So if there are 2,200 students, what is the ranking of the 1,100 students? The middle students.
Yeah.
It's a good indication.
Sure.
You know, there may be exceptions. For example, we may be getting very top students. That doesn't count. Or we may be getting some. For example, this year, because of the earthquake condition, we have some earthquake students.
Yeah, sure.
They had a special quota. So there may be exceptions, but the 1,100 students is a very stable one in terms of ranking. And that ranking improved greatly.
I see.
So it was some 35,000, now it's 16,000.
I see. Also, a lot of Bilkent's rankings and the job findings after graduation is very high. Do you do anything to ensure that, except the projects that you mentioned and the summer practice?
Well, I think the employers after graduation appreciate the Bilkent graduates.
Yes.
They see them and say, we want to get Bilkent graduates. You know, I talk to Bilkent graduates, they say, everything, you know, like if there's a presentation, they ask you do, because Bilkent students can prepare nice presentations, and then, you know, they are comfortable with PowerPoint, and they are comfortable in their English, right? But definitely, so English is a big plus.
Yes.
One of the difficulties of the university is English prep school.
Yeah, that also people a lot of complaints.
Yeah, they say it's too difficult.
Yeah.
It's too difficult. Yes, it is difficult.
I truly don't agree with them in this regard.
Because unfortunately,
in these times, you should know English.
You should know English well.
Yes.
And our English prep school is holding it tight, right? There's a level that you have to achieve before going into university, and that's another big complaint.
Yeah.
You know, some students come in to our university, spend 2 years, and still they can't pass it. And in that case, unfortunately, we have to let them go to some other university.
Yeah.
We don't like that. But we have to do it.
Yes.
Because we don't like because that's also bad. You know, because I've seen parents complaining about this. They said, we paid Bilkent University for 2 years, and then you throw us out.
But 2 years is a long time for a language. I mean, except it's Russian or Japanese or something. So we keep our standards. So this is one of the things that Bilkent does, and everybody knows it. And another thing, of course, we did in the COVID times is, these mirrors and stuff. Yes. Was that also your idea?
Yeah, that was my idea.
Which people also didn't like, but we got a mirror in the end, so why complain?
Well, the other universities were taking exams, students in the other universities were taking exam with cameras turned off.
Yes, and that didn't turn out well, that won't turn out well.
I've seen the graduates of those universities applying to us for masters.
Yeah.
And they do nothing.
Oh no. That's a very difficult truth, to handle. Well, I think Bilkent is struggling with, I don't know, you should know this better, but still, even the universities like Bilkent struggle with getting money and the funding because the economic situation is not very good in Turkey. Do you see any other ways of accomplishing this, getting the money flow?
Well, we are trying to get more money, of course, to the companies. We have some 20, 30 companies that belong to university. This is unique, unique in the world. Not just in Turkey, unique in the world. These companies do not belong to Doğramacı family or anyone else. It belongs to the university. University is the sole owner of these companies. And these companies employ some 30,000 people. And these people know that the money they make goes to education of Turkey. So they are proud that they are doing something noble, and they work hard, and they try to make more money. Of course, Turkey, economic situation in Turkey is difficult, but the companies are working hard to make more money for the university.
Okay.
But financially, we are okay. We are not in debt. Right? We don't have any debt to banks or anything like that.
Yeah, that's good enough. And I guess generate electricity for others.
Yes, one of the companies is Bilkent, which generates electricity for the campus. Plus, the heating comes from as a byproduct of electricity generation. So we are a very self-sustaining little economy. Plus, we started putting solar cells are now being positioned by Bilkent in different places, so that we can generate our own electricity. Currently, we are only generating about 10% of our needs from sun. But that's not that. It's a good start.
It's gonna go higher, I guess.
Yes.
With time.
Yes.
Let's get to your career. What are the fields of interest such as AI, that is in a recent trend, or quantum technologies? What are the fields of interest that you want to go in, or you would like to go in?
Well, I'm almost 70 years old now. I'm not in a position to change subjects.
That I know. Okay. I'm not suggesting you to change, of course. But.
Of course, new areas are emerging in electrical engineering. Some areas I have no clue. For example, AI. I have no clue.
I see.
But was it yesterday or the day before yesterday? I was on Zoom. Doing a research meeting at evening at home, and there is a new tool now on Zoom. Now you press a button, and it listens to the conversations and makes a summary of the conversations.
Yes, that was.
But I think it doesn't understand Turkish yet. You have to be talking English. Our meeting was in English, so it was a good summary.
Yeah, perfect. Would you, if you were young again, then which one would you go into? Do you see any?
Well, there are many potential areas that young people should go. And I'm not in a position, I shouldn't be suggesting in one particular area. Everybody should choose their own, it's their own future. They should choose whatever potential they see, things that they like. Okay, that's the area that they should go in. Motivation is the important part of being a scientist.
Inner motivation, sure. Do you still have any projects that you haven't had the chance to bring to life, and that could be because of insufficient offtake or other reasons that you, still would like to, or suggest others to do?
Quality education is a never-ending, battle. Yes, you have to go on this trail all the time. More you go, more distance there is to cover.
Sure.
There is never an end. So I think we can always improve our education.
Sure.
And of course, with changing times like this AI thing, how can we use AI in education? Well, currently we're not using it much.
We are not doing it well.
We can use AI instead of prohibiting use of AI. We can use it because it's part of, and if Bilkent students learn how to use AI in their daily lives, that's great.
Yeah.
We should not prohibit use of but this is something that our university administration or department chairs or individual faculty members should decide on their own.
Yeah, because.
But in my lecture, AI cannot answer the questions.
Yeah, not yet at least.
Not yet at least. I asked some questions to AI, chat GPT and so on. Nonsense. It's not yet there.
If it's improved, would you?
Yes. Well, if there is an improvement there, and there will be soon, we should be creative and find new ways of using this in the education system.
Yeah, the exams won't ever be the same. It seems like. What kind of path would you take to do more interesting, or I don't know, the ones ChatGPT can't answer better, I guess. How would you do that? Do you have any idea? Or homework?
I currently don't know how I can use ChatGPT in teaching, but when it comes along, when it improves, I think we'll find new ways of using it.
Sure.
Currently, I don't know.
I see. Okay. As far as I see, you have worked on projects that always sparkled new ones. How did you work on many projects simultaneously? And sometimes after a number, projects can be very hard to manage too. How did you ensure that balance when you were doing simultaneous projects at once?
Well, I was. Of course, I become an administrator, university administrator, most of my career, starting from 1986 till last year. I was an administrator. I was first a chairman, then associate provost, then rector.
Yes.
So that took half of my time almost. Maybe sometimes more than half of my time. In the meantime, I was also teaching.
Yes.
And I was also trying to do projects. Projects are important to learn the real life. If you do projects, especially externally supported projects, then you can learn things. And that what you learned in those projects will be helpful in your teaching and for further research. Doing projects is also important, but being a faculty member is more than full-time job.
Yeah.
You don't go home and relax because you always have to do something. I always studied, till midnight or sometime later. Wow. My students, of course, my students. They stay late. They send me an email at 2 a.m. in the morning. I answer them at 2:15.
Yeah, that's very good though.
So, and they ask, "Are you ever sleeping?"
And you answer, "No."
No, I do sleep, of course, but maybe about 5 hours.
Okay. And I guess your studying time has increased from the young years to...
Oh, yes. I study now more than what I used to study when I was in university.
Wow. That's interesting. I wondered if we are going to be the same. So you ensured that balance with sleeping less, I guess.
Well, it's not, when you get older, you tend to sleep less and less.
I see.
So if I try to sleep more than 5 hours, I just can't.
Oh, okay.
I wake up.
That's good. So how does one know there's no more questions to answer or no more to do in a particular project that you can, I don't know, go into the
next area.
Yeah.
Well, in a faculty member's life, of course, the interests change.
Sure.
And there are areas which get mature over time, and it doesn't make sense to make research on that area anymore. So then you switch to another area. For such things, actually, our university has a sabbatical system. You know, that means you leave the university for 1 year and go to another university and make a research there. And you stop teaching during that year.
Yeah, of course.
But the university still pays you while you're away. And then maybe you get involved with another project, another research area, and then you start working there. So it's something that our university I think our faculty members are using.
Did you have any such?
I had one sabbatical.
Okay.
But before I became an associate provost. Provost. Before I became a provost, I was 1 year in Stanford.
I see.
As a visiting professor.
What research was done enough that you went to another university, Stanford?
Yes. So that helped me start in 2 new projects.
Yeah, we can go into the projects.
Yeah, one has to do, because you're a physics student, you might understand, one has to do with atomic force microscopy.
Yeah. I related to that.
Yeah. The other was about capacitive micromachined sensors, the micromachining, doing micromechanics on silicon.
Yes.
Mostly on semiconductors. So it's called
integrated fingers.
Like area of MEMS is called microelectromechanical systems.
Okay.
So I was introduced to that area while I was in a sabbatical, and I continued to work on that area.
And that helped, I guess.
Yes, of course, the sabbatical helps.
Before sabbatical, what were you working on that ended, I guess?
Yes, some areas that I worked before that ended. I started working in new areas. And I was working in well, I was one of the first integrated circuit design of Turkey was done by my students at Bilkent University. First IC of Turkey was done by Bilkent students.
Can you a little bit go into what integrated circuits are and how they work?
Yeah, integrated circuits nowadays, of course, are everywhere. In our cellular phones, there are many integrated circuits. Integrated circuits are made usually from silicon, and they contain nowadays millions and billions of transistors.
Yes.
Okay, so how to design such things?
Yeah.
And that requires special expertise. And this is something I didn't learn at Stanford.
Yeah.
I learned it later on my own.
Wow.
And I started teaching it. And actually, I must say, I learned it by teaching it. If you want to learn some new area, you start teaching a course on that area. And you are only a few weeks ahead of students.
Yeah.
Of course, you have to have basic knowledge.
Yeah, sure.
But then you can build on top of it. I taught many new courses which I didn't know.
Yeah.
So in the first year, I was just a few weeks ahead of students. But then later I learned more and more.
And probably their questions also help you.
Oh yes. Sometimes they ask questions I have no clue. I have no idea how to answer. But then I'll answer you later. And that night I worked hard and I learned it. The next day I tell them.
Perfect.
So it's always learning.
Yeah, definitely. From what I've seen from your article, you have even come up with a theoretical model to explain observed transducer behavior. Can you explain me the transducers and your work with air-coupled transducers and water transmission experiments that you did.
Well, this is part of this MEMS experiment. I have a number of papers in that area, and that has to do with building ultrasonic transducers.
Yes.
Meaning, ultrasonic means inaudible. Frequencies higher than what our ears can hear.
Yes.
Something, our ears can hear for young people up to about 20 kilohertz, 20,000 hertz.
Yeah.
But above this, we can't hear. Mosquitoes can hear. Bats can hear.
Well, yeah.
But we can't. But if you go even higher, even mosquitoes can't hear.
Yes, so
right? So a very higher frequency. This is the frequencies, for example, at megahertz.
Yeah.
A couple of megahertz. When you take an ultrasound scan, many people got ultrasound scans, and this is done by sound waves at higher frequencies.
For babies,
to see the babies, for example, to see the health of a baby, to see the heart beating of a baby, you need to use ultrasound. So ultrasound uses, in many current technology, they use piezoelectric transducers.
Yeah.
Piezoelectric materials like something called PZT, a ceramic material that's piezoelectric, and that generates sound waves. And there's an electronic scanning.
Yes.
Phased array electronic scanning of this. And that way you can get an image of, let's say, a baby. So the sound waves are focused, and the reflected waves are get collected by the same transducer, and that then maps onto a screen as in the form of an image. Yes. So the points that reflect the energy most, sound energy, are, for example, when there is a change in the density of the material. So for example, if you go from a soft material or a liquid to a harder material, then there will be sound reflection, and that reflection will be detected by this transducer. And so our research was how to make the transducer from silicon, rather than from piezoelectric crystals.
I see. And they behaved differently than you expected?
Well, no, it actually makes it less costly to build and more higher performance. And there are now companies who can build handheld ultrasound.
Wow.
And some of my students are working in that company. From Bilkent. We have a large presence in that area from Bilkent in the world. So many people who work on this area are from Bilkent.
Most likely. What is the theoretical model that you have come up with then? Because you said there are no weird behaviors, but you still needed a model to explain what they were doing.
Well, of course, we worked on several things, like how to model this, how to model the behavior of such transducers, so that they can be easily designed. So we had some work.
That's what you mean.
Along with my colleagues and my students, we worked on that area. And we have some theory developed to model such devices.
What was different when looking at PZTs, now silicon? What was the difference there?
Well, the difference is, of course, in the bandwidth. You can make wider bandwidth transducers. Wider bandwidth means higher resolution in the depth direction. So you can get sharper pictures.
Sure.
And you can also use higher frequency, which means higher resolution. Currently, the company which is making these handheld ultrasound scanners, it's also very inexpensive.
That's
like about $1,000. You can buy a handheld scanner which connects to an iPhone. So iPhone screen shows the ultrasound.
And the baby.
Yes, and you have an iPhone connected to a cable to ultrasound there's a company which does this in the United States. I think that would be, yes. So one day it will be something you can buy an ultrasound for your own.
Okay. That's good. So.
But currently, with PZT, the things are very expensive. The instrument is big, and only the hospitals or specialized places can buy it. It's an expensive equipment for us currently. But with the silicon, it's going to get cheaper. And one day, I think you can buy an ultrasound scanner for your home.
Okay. Yeah, maybe at some point medicine will be in the hands of people.
Yes, and then it's connected to a doctor, and doctor will look at the image and say, you need to do this and that.
Yeah, would be
I think there will be a lot of, because the world population is getting older and older, medical technologies will become important, I think.
Sure.
And it's...
do you find that troubling, the population getting older and older?
Well, it's a fact of life.
Going down.
It's a fact of life. We have to live with it. Sure. We have to learn to live with it.
Yeah.
I mean, you cannot ask people to make more babies. You have to live with it.
Yeah, but the birth rate is troubling for the whole of humanity.
Yeah,
it seems like,
especially in the Western world. In Europe, for example, the birth rate is gone down. Actually, the populations are coming down.
Yeah.
So they are trying to solve this problem by inviting other people from other Middle Eastern countries, African countries, etc.
Yeah. Do you expect that to be a problem, or will we find a way to live with it somehow?
Well, it is a problem, one of the problems of humanity. Of course, global warming is the greatest problem. And there are many problems that the world faces.
Since you mentioned AI, there are some people also finding that troubling for humanity as a whole. Are you one of those people, or you don't see a problem? AI troubling humanity? No. AI
is not something that will be a trouble. Of course, there will be bad uses of every technology.
Sure.
Every technology has, inappropriate uses. But I don't think, AI can be prohibited. It will be there, so we need to learn to live with it, and we need to use it in the positive direction. We need to learn it.
Sure. You have also improved techniques up to 10 to the -3 angstrom with this atomic force microscopy. The precision was really great. And can you tell me how you made that possible and principles of interdigitated silicon fingers?
Well, I'm not an inventor of this technology. I'm one of the first people who worked in that area. Atomic force microscopy, how to improve the resolution, how to detect it well, and so on. I have some patents on it, and some of these patents were getting royalty income. So it's nice to receive a check with a royalty income. It's nice because it's a result of your brain work. Not the hard work, but it's as a result of your invention. You get a check.
Yes,
that's one of the. That's a reward. One of the biggest rewards of being a scientist is when you find something.
That's even greater.
This is a eureka moment. Archimedes' eureka moment, right? I know how to say it now. For me, that usually happens when I'm taking shower in the morning.
Incredible.
Yeah, that's usually what happens. When I'm taking a shower in the morning, I know how to do it.
It usually happens either in the bathroom or in the shower or in a walk. I didn't ever see a case where it's different.
Yeah, this happens to me morning shower. Probably in the evening, that's in my
back processing.
Processing in my brain. In the morning, when I'm taking shower, it comes out.
Yeah. That's awesome. And can you tell me a little bit about this interdigitated silicon fingers? How does it work? It's from the pictures I've seen, it's literally similar to fingers, triangular structure going one by one.
This is something I invented. It's a micromechanical, microelectromechanical structure built from silicon. It's a cantilever with a sharp tip in front.
Yes.
So this is the AFM's microscope's tip. Very sharp tip, you know. The tip's sharpness is in the order of angstroms. And then the position of, as it touches the surface, of course it doesn't scratch because it's so light. It's a very thin silicon cantilever that touches the surface. And as you scan the surface, it goes up and down. And the interdigital cantilever that I found is how to measure the position of this cantilever in an atomic scale. Using a laser beam reflected from this interdigitated structure, it generates optical reflection, and from the position, optical reflection's magnitude, you can determine how much it's deflected.
Surface, yeah.
Yes. And that way you can make an image. And that's what's called atomic force microscope image.
Okay. You have been most interested in imaging techniques, acoustic and with atomic force microscopy. What made this interesting for you?
Well, acoustic imaging was my PhD thesis.
Yeah,
so that was my PhD thesis. I worked on acoustic imaging using even, ultrasound works around 2 or 3 megahertz, 5 megahertz, thereabouts. But you don't get a high resolution. You just can see for example, unborn child. So the dimensions of resolution is slightly better than a millimeter.
Okay. Yeah.
So that's the order of resolution for ultrasound.
Yeah.
But if you need a microscope, you need micron kind of resolution.
Yeah.
That means we need to use even higher frequencies. So in my PhD thesis, I used gigahertz to generate sound. Sound waves at gigahertz. There the wavelengths are much smaller. For example, at 1 gigahertz, the wavelength of sound in water is 1.5 microns.
Oh, wow.
At 2 gigahertz, it's even less, half as big. Okay, 0.7 microns, 0.75 microns. Yeah. So I built at the time, in my PhD, I built a microscope that uses these very high frequency sound waves to generate an image.
Okay.
And this microscope is still being used.
Oh, really?
There are companies who are building it and selling it, acoustic microscopes, because you can see underneath the optically opaque materials. Optically opaque.
So it's front and back.
Well, but it's in a microscopic scale.
Yeah.
Very small structures, mostly integrated circuits and stuff. So you can zoom in and find out what's happening underneath the optically opaque structures, and you can image that.
Do you know when it's used for cells?
It was used for also. We used it for biology also. But since most biological cells are also optically transparent, there was not a big advantage in using acoustic waves.
Yeah.
But most materials are optically opaque.
Sure.
The light doesn't go through, so using an optical microscope, you cannot see beyond opaque materials. Right. But with acoustic microscope, you can see what happens underneath. And there are companies which build the instrument that belonged to my PhD thesis many years ago. And there are some, I don't know, some Japanese companies right now are still building and selling it. There is a German company building and selling it, and actually its fabrication happens in Sivas.
Oh.
They have an office in Sivas, and they are fabricating this instrument. And one day, the owner of this company, a Turkish guy, who owns this German company, but operates in Sivas. He was from Sivas. And he read all my papers and so on. He said, one day he showed me how we are building. I was very surprised that somebody's building my PhD subject in Sivas.
How nice was it to see the research that you did coming alive?
40 years ago, 50 years ago.
Yeah. Yeah. So it was great for you as well.
Yes.
Wow. Okay. How far do you think can imaging go? You have been up to 10 to -3 angstrom. Do you see it going lower and lower, or?
Well, imaging is in the frontiers of science.
Sure.
One imaging, of course, seeing what's very far. Building big telescopes.
Yeah.
In the outer space, so that we can see what's going in other galaxies and so on. This is one direction.
Yes.
The other direction is, going smaller and smaller and finding out what's happening in nanometer scale, angstrom scale, and so on. So it's a research area that people are working on. How can we make things smaller and smaller? Yeah. For example, people are now talking about transistors, which are nanometer scale. Scale of the transistors are a few nanometers. A few nanometer transistors is currently being fabricated. Yeah. And how do you image them? How do you, this is an area that will keep people busy for many years to come.
Do you see a technological limit for this, or physical limitations?
Well, there is. People always find new ways of doing things. Yeah. You think you hit a limit, but then you
somebody
comes along with a bright idea when they are taking a shower, and then then all of a sudden there's a new frontier, and the people work in that area for maybe 10 years, 20 years, and then something new comes out. Converting a new idea to a new technology takes 10 years, 15 years, 20 years.
I see. How did you solve the problems that you encountered while you were doing the research that are only technological? Like, when something didn't work with the circuit, what did you do when something didn't work with the auto-enforced microphone?
When you hit that wall, you have to work around it. Go around the wall. When you hit a wall, and try to struggle to pass the wall, but the ball is big enough that you can't do it, then you have to find another way of going around the wall.
Yes.
Okay? So you have to be creative in finding new ways of solving things.
Do you have particular examples where you struggled for a while and then you find a way to go around?
Yes, of course, there are many examples.
Yeah,
many of the research that I do is, something you need to find a solution to something that other people couldn't find, and you have to be creative. And you find a new solution. That's the eureka moment. Then you try to realize it. And once it's there, then you publish it.
Yes.
It's when you publish a paper, this is one of the great joys of being a faculty member.
Of course.
You have to publish it in a good journal, not just any journal. Currently, there are journals which print whatever you write.
Without even looking, right?
When you pay the money. I never publish in those journals.
Nobody should.
I don't know, but I don't.
And that was what I was going to ask next. What are the best and worst parts of doing the research for you?
Well, worst part of current research arena or being academic life is corruption.
Yes.
There is, unfortunately, widespread corruption in academia also. People steal other people's works and they publish it as their own. Plus, they publish the same thing over and over again.
Yeah.
They repeat someone else's work and try to publish it. And nowadays, there are journals which will publish whatever you wrote.
Yeah.
As long as you pay, they will publish it. So some people have tons of papers, but all of them are garbage.
Yeah.
So this is unfortunately the universities are ranked according to number of papers they produce, irregardless of whether the papers are good or bad.
Yeah. And
some papers, some journals publish a lot of junk journals, a lot of junk papers, and a lot of faculty members in universities elsewhere, not in our university, they publish a lot of junk papers, but because their number of papers is high, they are ahead of us.
Yes.
So one of the things that they criticized me while I was being a rector is how come we reduced our ranking? You know, when the first year we became the rankings first published, we were 112th in the world.
Wow, great.
That was in my second year of rectorship.
Then corruption started.
Then, of course, people saw that this is an important thing, being high in the ranking, and the corruption started, and now we are lower and lower and lower. And so, if you read other people's criticism about me, they say, this guy, ranking has gone down, Bilkent has gone back. But that's not the case. Okay. It's just the corruption increased in other places.
I see.
This is my opinion.
How did you figure out who to take, who to not? Like, if you don't select the faculty members greatly, you are gonna have this corruption as well, for sure. So, what are the ways to ensure that's not?
Well, in our university, we said, you shouldn't pay journals to get your paper published.
If they're taking it without money, then it's fine.
Well, if the journal is accepting your paper without taking money, then it's okay. So that of course, that reduced the number of papers that we published.
Yes.
And actually, when I was a rector, I was part of the Inter-University Council. And I don't remember how many years ago, maybe 4 or 5 years ago, I convinced all rectors that they should do the same.
Okay.
They should, any paper that's obtained by paying the journal should not be counted in anything.
Yeah, of course.
They accepted it, but after a few years,
they couldn't
resist this pressure from faculty members, and they removed the rule. And nowadays, in many universities, people just pay and publish.
Yeah, but what if all of the journals at some point go to the money system, capitalism or something?
I don't think so.
Okay.
Well, there will still be journals which will take. There's a conflict of interest when you pay and publish.
Yeah.
They have no reason to reject your papers. For example, currently I'm reviewing a paper by Chinese authors. I found many errors.
Yeah.
So I will report this, and I'll see if it gets rejected or accepted. I'm one of the reviewers.
Nice.
Sometimes there are. I spend a lot of time in reviewing papers.
Yeah, that's a very important thing.
It's part of being an academic.
Even in nature, there are some really funny errors that people overlooked.
Yeah, I spend a lot of time. I try to repeat what they've done. I can find errors, and I report this. And then sometimes the editors are also corrupt, and they will they will publish their friend's paper, even though it's full of errors.
Yeah, yeah. What are the main problems in your areas which you actively try to solve in your brain, in the shower? What problems?
Well, one of the areas that I'm working on now is how to increase the efficiency of electronics, so that they spend less power in warming the world.
Okay.
Global warming, because nowadays a significant portion of the global warming comes from base stations. You know base stations? The base stations transmit and talk to our cellular phones. It's now a significant portion. With 5G technology, there will be even more of cellular phones and therefore more base stations.
Yeah, of course.
And how can we improve the efficiency of those devices is an area that I'm working on.
So it also goes into communication.
Yes.
Okay. And
well, it's basically electronics portion, which generates analog electronics, which generates the efficiency.
Why is it tricky to do so, increasing the efficiency right now, specifically?
Well, currently there is an efficiency, maybe around 30%.
Okay.
40% efficiency. So if you put some energy into your cellular tower, 60% goes to heating, 30% goes into electromagnetic waves.
Okay.
And because it's getting hot, they need to put also coolers there.
Yeah.
And that cooler is also taken to cool it down. So it's a very inefficient operation. You spend a lot of energy, and basically you heat the world globally. You heat just to be able to transmit that cellular power energy. And so it's an area that we are working on. Each time you improve something, that's good.
So which part of this system are you trying to attack? The cooling, the heating?
Well, I'm trying to attack the power amplifier at the end of the chain. RF power amplifier.
Yeah.
How do we improve the How do we improve the efficiency?
Okay. Hopefully you're going to solve that too.
Well, it's a difficult problem, so we can maybe contribute a little bit. 1% contribution is also important.
Yeah, good enough, for sure. You have been very active in the field and you still are. What are your future directions, maybe after this one?
Well, I'm 70 years old.
But
don't expect a lot from me.
You are still very active though, so I would expect.
I'm 70 years old, so young people, my students, will be doing new things.
Yeah, okay. And how did you find this getting older situation? How well did you work? How was your efficiency going up and down? Can you briefly mention that?
Well, it's your age is something, and how you feel is another thing.
Yeah, exactly.
I feel I don't feel old. You know, hopefully I will be participating in the Republic Run.
Yeah.
Is it tomorrow
I would like
or something?
to see you there. Yeah, it's tomorrow.
Yeah, so I will be there. No, I'm not sure when is it. Okay, sometime. There's a lantern walk. Lantern walk. So hopefully I'll be there too.
Okay.
We'll see.
Okay, thank you so much for coming and thank you for indulging my questions. Very nice to meet you.
Thank you for inviting me.